to start, so don't be delayed. So first of all, a warm welcome. Thank you everyone for joining the webinar Retrofitting the Blue-Green City Quarter, Innovative Products and Services. Today we have invited 3 speakers. I will introduce them now. It's first of all, I will give the floor to Martino Gubert. He's a researcher at the Institution for Renewable Energy at Eurac Institute in Italy. The second speaker will be Oliver Ringelstein, manager at INTEWA GmbH in Germany. And our third speaker will be Dr. Sergio Andri, a technical officer and specialist and research developer from HARPO Group in Italy. Yeah, so thank you for contributing to this webinar and giving your input. And I will go on with the next slide. So first of all, I will say some words about myself, webinar host. I'm Katharina Kopp and I'm working for the EFB, the European Federation for Green Walls and Green Roofs and Walls. And I'm assistant to the board. And today is my first time hosting a webinar. That's quite exciting. Yeah, the EFB is the European Federation of Green Roofs and Living Walls and was founded 1997, and we are a non-profit organization. And the EFB is kind of an umbrella organization for all green roof and wall associations in Europe. And yeah, you can see all 18 associations and 20 member countries. It's quite a lot. So yeah. And then we also have a extended networks with the VNG, LCA, IFLA, and So Green. And yeah, if you want to become also a member and a supporter, I will say a few words more about it in the end of the webinar. So first of all, I would like to give a word about our sponsors who are supporting us with some funding for this webinar and other webinars. So a big thank you for Six for Green, which is a system provider in the green sector with a wide range of products for green roofs and gardens. And they supply products mainly in Europe, but also worldwide, and supporting us to host those webinars. Thank you. Other sponsor who is especially sponsoring this webinar is the HARPO Group, the section verdepensile. And HARPO is a long-established company from Trieste. Today also our speaker, Sergio Andri, is from working for HARPO verdepensile. And the company was founded in 1897 and is specializing in innovation, nature-based solutions for mostly Mediterranean climate. And since 2001, HARPO was also entering the roofing sector, and since 2003 is HARPO is establishing green roof solutions. And then we have another sponsor, it's INTEWA, also the company from our webinar speaker, and INTEWA is mostly working in innovation systems regarding water treatment, reuse of water and stormwater management. And the company combines many years of experience in research, product development, international projects, and they also work closely with universities and professionals along the sector. So thank you to our sponsors. And now I would like to go on with the agenda for today. As I already introduced the setup, I would also like to mention that this webinar is recorded. So later it will be available on YouTube. So for now, we have almost 30 visitors for the webinar. Thank you so much for coming. And yeah, the webinar will be recorded, so we recommend you to turn off the camera and also to turn off your microphone. And we would like to address to you that if you have specific questions regarding our speakers and the input, then you are really welcome to write down the questions in our chat. And in the Q&A session, we will try to answer them. And you are welcome to write down the questions anytime. So regarding our presentations, we will first have the presentation from Martino Gubert from Eurac institution regarding the Infinite European project. After we will hear a presentation from Oliver Ringelstein from INTEWA, a German company, and then we will go on with Sergio Andri from the Italian company HARPO. Then we have the Q&A section, and then later we you get information regarding sponsoring, what's coming up next, and yeah, events we are involved in. All right. Then I would like to give the floor to you, Martino. You can share your screen.
Yeah, here we are. Good evening, everyone. Just sharing my screen. Let me know if everything is okay. I'll put in presentation mode. That's okay.
Perfect.
Perfect. So first of all, good evening. I'm Martino Gubert. I'm an engineer and researcher in Eurac research. My research topic are dealing mostly on industrialized in building sector, so prefabricated facade, and we are developing also envelope technologies. And then I'm actually moving to circularity and eco design concept still for this kind of industrialized element. Today I'm gonna show you like a very broad presentation to the main results of the Infinite project. I will try to focus a bit more on the green solution that we develop, but in any case, I will show you like a very overall concept of this Infinite project. What is Infinite project? Is a Horizon 2020 project with a total of 10 million budget. We started in 2020. We have 20 partners that coming from 8 different European countries. What's the main aim of the project? Is to increase the market penetration of this industrialized all-in-one envelope system for retrofitting the EU building stock with a very high level of performance, so NZEB performance. What's the context? So right now we have a very low deep renovation rate. Is around 1%, and based on the fact that we needed to decarbonize the EU building stock within 2020-30 or 2020-50, we really need to fasten this renovation rate. So we think that we need to do it right and fast. So we think that the best solution is to go on the industrialization and digitalization of the building sector. So the main concept that is behind the retrofit concept of Infinite is the industrialization. So moving the manufacturing of the renovation from the site to the factory, and then from the factory to the site again, just to install it in a faster way. The peculiarity of Infinite is also to adding a set of multifunctionalities. So not just a passive prefabricated facade, but adding a set of multifunctionalities that I will present you briefly. So within the project, we have 5 main pillars. So we have stakeholder engagement in the center. So all the activities we've done so far, we try to engage as much as possible all the stakeholder in the value chain. Then we have a set of development technologies. So we developed 5 different industrialized kit for the retrofit. Then we developed method and tools. So a BIM platform with a set of plugins to perform the analysis from the architect's point of view. Then we have demonstrators. We have 3 real demo cases, one in Italy, one in France, and one in Slovenia, where we test these new technologies. Then we work also on business models and exploitation. So how these kind of activities can go ahead in a sustainable way. So today I'm just mostly focused on technology and demonstration. So what's the technologies? We start with the prefabricated wood-based facade or roof element. And then the idea was to adding 3 different cladding system and integrating elements. So regarding the cladding, we have the green, BIPV, so building integrated photovoltaics, colored and hidden, so you cannot see the cells, and then BEAST, so it's same as a BIPV, but is solar thermal. Then we have integrated elements, so all the energy and fresh air distribution, so means a ventilation machine integrated in the envelope with all the ducts to provide heat, cooling, and a renew of air within the apartment. Then finally, we work on smart glazing, so working on the glazing to avoid overheating inside the apartments. So just some insight from the mock-ups we did. We did several mock-ups. I'm just putting the one that includes green facade. So the concept for the green was we have a complex system that is based on several layers, that is the fabricated wooden-based facade. Then at the external part, we thought to include a green element. So the first question is which kind of green solution? So we start to define a set of criteria to define this green module to be applied to the facade. So first should have low weight, because still all the facade without any cladding is around 60 kilograms square meter. If you apply this kind of solution to an existing building, so probably you can reach 80, 85 without having any structural problem. So we need low weight, low thickness, because still we have like insulation on all the layers. So we already have about 20 centimeters or something like this. So we cannot apply other 30 centimeters, because otherwise we will have also problem with the distance to the other building and so on. Then should be easy to install, have a reasonable cost, and then possibility to pre-install off-site. We start the analysis, we evaluate different solution for the green. So the self-climbing plants was not so interesting in the beginning, because we had like the greening going quite late, then climbing plants, and then living walls. Due to the let's say the criteria we select, the most promising one was the living walls, but then still we keep the climbing plants as a possible solution. Then we go ahead, we define that probably the linear was not so suitable due to the high weight and the thickness. Then we move to modular, fabric or not. So this is just an example of the sheets that we produce, a sort of analysis of market analysis of different solutions that can be applied for each of the system I presented you before. So this is just an example. Then we started to design the mock-up. It's a quite large mock-up, is 16 square meter mock-up, south and east oriented. We design it. In this case, we select Terapia Urbana solution that was matching most of the criteria we select. Then we realize the mock-up in the factory of the manufacturer. As you can see, was prefabricated element. We install it in our lab in Eurac. Then we install the green element with all the plants within it. We plan a very extensive monitoring campaign, monitoring the rear ventilation gap behind each of the cladding. And then finally, the result is to have this kind of mock-up with, on the left, the colored, let's say, square and element are BIPV. So you cannot see any cells. Is the photovoltaics hidden by colored glass. And on the right, you can see the beast, and then on the bottom, the green part. So based on the results we have, of course, the green show a lower temperatures on the back of the rear ventilation, but we are now working on writing a paper on this topic. Jumping to the end, I'd really like to show real cases that we are doing right now in Infinite, just to show the potentiality of this industrialized approach. So we have 3 demo cases. I will focus mostly on Slovenian and Italian demo, since the French one is only related to the BIPV facade. So we couple different kits in order to retrofit within ZEB level the building. First is the Slovenian demo. As you can see, it's quite a large building with low-income people living in there. Here we apply a concept of retrofitting with the prefabricated facade, but also acting a sort of densification concept, so adding a new floor. So the concept was, okay, let's remove the roof, let's adding a new floor, and then let's put all the retrofit solution in order to achieve the ZEB level. So we did it last year. So these are the prefabricated facade just attached to the existing building with a quite large insulation panel. Then also for the upper floor, we realized all the prefabricated element with the, let's say, ducts and the ventilation unit embedded in the factory. And so we increase an additional floor. And that's the status right now. So it's the latest picture I have, but I know they are finalizing it. As you can see, there is like a large part of photovoltaics, but that you cannot see that is photovoltaics, but is a prefabricated facade with photovoltaics. Then an upper floor where we realize 6 new apartments that the building owner sell to pay all the rest of the building retrofit. So that is a very nice business case that we are evaluating now from the cost point of view. So we will run some simulation and we will give you more feedback in the following month. Regarding the green, in that case, we had just the opportunity to install a very small modular element, but still was interesting for the owner, because this kind of solution could be nice to be added on the terraces in order to have like a sort of a small place where the green can grow, and then probably giving some refresh during the summer period. Regarding the Italian demo, it's quite a small building, but we apply the full solution we had. In this case, we couldn't apply a new floor due to the structural reason, and always due to the structural reason we had a constraint of the weight of the facade. So that's the concept, to cover it and to do new balconies in order to have like the ventilation unit embedded into the balconies. We had like a very extensive design. As you can see, there is a double skin all around the building with these kind of prefabricated elements. That was quite nice to be integrated. Then we realized it in the factory in North Italy, including all the pipes within the prefabricated wooden base facade. Then there was, so of course, transportation from North Italy to Florence. Then from Florence, just applied to the building. That application was very fast. Of course, the preparation of the sites take a bit of weeks just to prepare the buildings, but then the installation of the facade itself takes just a few days. Then the level of prefabrication was very high. So we arrived to, at the end, having a very nice results. In this case, as you can see, then we remove the protective pellicula of the passive cladding. And on the right, you can see the photovoltaics, that is the dark dark red, and on the left is still to be installed, but we install it at the end. So that's the final version. You can see on the back the old building that was the twins building. So you can see before and after. And this took just a few months to be realized and finalized with a heat pump, with the photovoltaics to feed the heat pump. And this is a very great results. Then I'd like just to give you some pointer regarding some lesson learned, both from mock-ups and from the demo implementation that we have so far, just to start the discussion. So at the mock-up level, I was focusing mostly on the green kit because this is the main topic of today. So we realized that the type of cladding can really deeply affect the maximum weight we can apply to the existing building, because you thought in the beginning to have all the space you want to apply this kind of solution, but then in the reality, the engineer said that, okay, the maximum weight you can apply is 80 kilograms. With 80 kilograms with that kind of facade is a challenge. So regarding the green solution, except the fact that living walls can have a very low weight, in general they are quite heavy. And probably an interesting solution that we are discovering now and we are pushing now is the climbing aids, even if you have the time, a lower time to cover the facade with green. Then the living wall is a very nice solution because it's interesting due to easiness of installation, thickness, microclimate that can have in the surrounding, weight, and final aesthetic. But to us, we discovered that there are some topics to be highlighted. So first is a high sensitive to weather condition. So summer, winter can have a very impactful on the solution. Low capacity to survive without irrigation or fertilization, so a sort of high dependency of this solution, because the soil within the pocket of the textile are very limited, so you need really to have a high dependency. High maintenance, unfortunately, high cost, and high level of control needs, that is clear to the dependencies. And maybe we are thinking about that is suitable for this kind of application. Maybe we have to think about other solution, or maybe this kind of living wall can apply to the other kind of application. Regarding demo buildings, we know that industrialization is a reality, and we had a confirmation applying this solution to the two buildings. And then we have, regarding the green solution, we need to work on the overall cost because it's still quite high. We know that social houses or low-income people cannot afford this kind of solution due to the cost related. And then we realize that there are more common benefit than direct ones to the building, And then maybe we can move to some more simple and easier solution to be applied. Then finally is that the building owner in general are afraid of the maintenance topic, so irrigation, cutting, cleaning, etc. So that's the main feedback we have so far. That's the consortium of the project. I'm the coordinator, and that's all. And thanks for the attention. I hope that I was in my timing.
Yeah, thank you for the presentation, Martina. And we already got some questions in the chat, so I would like to ask you, do you want to answer them now or later?
As you can see, do you?
It's
so
only
first,
four. Maybe we can take them now.
yeah, okay.
So do you, the first question is, do you see a phase change material or storage in your facade?
Yeah,
And
I think that this could be a very interesting solution, this phase change materials, but we didn't apply so far. We just focus on mostly on the multifunctionality, so it could be a very nice idea to include this.
okay.
And yeah, we install building system. So we install a ventilation unit that run with the pipe. So from the heat pump, we connect this ventilation unit embedded in the facade that exchange from water to air, heating, cooling, and renew of air, and all the ducts go through the facade till the apartment.
Yeah.
About the cost, okay, different compared to conventional facade. The main topic in general is the cost. This kind of solution right now is most costly than traditional ones. Of course, the first idea, you need to compare this kind of solution that is for deep retrofit with a deep retrofit traditional solution. So means we need to reach at least the same level of performance. So a deep retrofit with the traditional is cost still quite high, but yeah, we are 20% higher than the traditional one right now. But we are working to lower this cost. But that's we think that is quite promising due to industrial uptake. How about fire protection? Still, we are in 1 week. We are doing the fire test on the BIPV facade with the prefabricated facade in France. So we will see the fire protection impact on this solution. But in any case, we are working also using fireproof material like mineral wool, or even the cladding are mineral wool pressed, high pressed mineral wool. So we work a bit on this topic.
Okay. Yeah, thank you, Martino Gubert, for giving us a general overview regarding the whole aspects of retrofitting and generally, but also presenting Infonite as a project and your part as our research institution in it. So when there are no more questions, I would like to go on with our next presentation from Oliver Ringelstein from the INTEWA company and presenting the Drain Max system as a product. Oliver, can you please share your screen? Great, thank you. Then the floor is to you.
Yeah. Okay, good evening all together. And thank you, Katharina and Martino, was very interesting. What you can see here is the water loop. So this means, this what our vision and plans is. We want to close the water loop. And what we do is, on the one hand, let's say what you mentioned before already is we use all the water sources we can get. This can be either rainwater, grey water, or wastewater now. And also, we want to get rid of heavy rainfall events to avoid the flooding, which is a big topic today due to climate change. In the presentation, I would give you a quick, I have only 15 minutes, overview. First, I believe it's interesting is our case study, the INTEWA building. And so he want to answer the question if it is possible to be water self-sufficient and energy neutral in our own smaller company building. Then I will give you a quick overview about water reuse and then head over to stormwater management and water shortage technologies, references, some references, and interesting also maybe is some future visions, also research and development project. Our systems now, they contribute to sustainability a lot meanwhile. So we are 30 years on the market and all the systems installed now save every year more than 5 million of water, and we infiltrate more than 8 million cubic meters of water. So we have done something. It is not a lot if you compare this with the big cities. So we have a lot of work for the future to do. In our own company building, now we want to answer the question if it is possible to be water self-sufficient and energy neutral. What you can see here is the old facilities, and this energy-wise and water consumption, roughly spoken, was a catastrophe. Very old buildings in Aachen, which is located in Germany at the border to the Netherlands and Belgium. And 6 years ago, we had the chance to get one of the last, let's say, plots in Aachen in the city. And here you can see our company building. It is a 3,000 square meters of plot. 350, office space, assembly and development 350, and so on. So we are about 20 people here in this, 20 co-workers here in this company. So first, what we have installed is our own potable water from rainwater system. And this is something special. Probably we're still the only company all over Germany doing this. Why? It's not that it is so difficult, it's more the question of the regulation. But we did it. And so we, what you can see here is the rainwater harvesting tank and our treatment unit. It's an ultrafiltration, active carbon, and UV. And with this technology, we get the best water to our mind you can get from our own roof. But we want to demonstrate what you also can do. And this is, for example, the wastewater. So the wastewater normally is going into the public, into the municipal sewer system. Here we have installed an own small system, and we recycle the water, and the water here is reused now for toilet flushing, also can be used for irrigation and so on. So for reuse water qualities. The green roof is also a water source. Of course, green roof has a lot of other advantages, such as the cooling by evaporation and so on. But a certain amount of water is collected in a separate tank, and we can use this water again for the irrigation of the green roof. This is more or less not a water source, but on the other hand, it is, because we fill up the groundwater levels. Interesting in our building is that everybody here in the city would say, no, this is impossible. Why? Because we are located here on 6-meter layer of clay. And so all the planning engineers, they explain it's impossible to do infiltration. So, but we have not been convinced, because we are in this business and we tried different technologies, and with evaporation, with these grass roosters, and it is possible at the end. You have to infiltrate through a large, let's say, surface, and then it's getting possible. We also have, of course, some areas, 50% with trees and bushes and so on. Only a quick information regarding this energy topic. We have a deep hole drilling to 100 meter to get the warm water. It's not geothermic water. It's simply the temperature of the environment of the ground. We have a heat pump, and we have the underfloor heating and cooling. With the same system, we also cool our building down with nearly no energy, because we have a high COP of nearly 6. You also can see results in a study from the University in Berlin of the building. So we have also the ventilation with heat exchanger, which makes a lot of sense. This can save, again, 50% energy. And our own PV system, I would say it's tiny if you compare this with others. So with a 17 kilowatt only, we can cover the whole consumption and even give 3,000 kilowatt hours per year back to the supplier. So altogether, with the building, yes, of course, we're water self-sufficient. We are energy neutral. We are not energy self-sufficient because we don't have the batteries by now. And most interesting is here on the right. You can see how much do we have to pay for the building. It is less than 500 euros in a month, which is less than 5% of the same situation with the old building. So it's really price-wise very, very interesting for us as well. Yeah, then we have a funny marketing idea. So if there is too much rainwater, of course, with our roof, we have too much rainwater. Most of the European southern countries, it's not enough rainwater available. But what we have done is we brew beer in a small craft brewery in Belgium, and lemonade, and kind of Coke. But this, again, is not, let's say, to sell. It's more for marketing, to explain to people that you can do much more with the rainwater instead of simply flushing the toilets. Yeah, the water reuse, we are focusing on medium-sized systems. Let's say medium-sized. Why? It is commercial, maybe up to 50 cubic meters a day, what we can save in a standard range. We also can deliver and offer other systems, and we use those technologies now for grey water recycling, potable water production, adiabatic cooling. and reuse of the water, of the wastewater from existing sewage treatment plants, for example. The idea with the complete systems came in the last, let's say, 10 years. In the beginning, we delivered only components, and then the customers, they said, no, we need complete packages, otherwise it's too difficult. It's also getting cheaper if we deliver the complete package. Here you can see a sample for greywater recycling system. I don't have enough time to explain the technology, but it's quite simple. It's a membrane bioreactor, so biological treatment and membranes, roughly. And interesting is that with the greywater recycling system, you don't need a lot of space, and especially for all the countries in the southern areas, but also for bigger buildings, and especially for all the buildings now with the green roofs, we don't have enough rainwater anymore from those buildings. And here, greywater recycling is getting more and more popular and interesting. And as you can see, we do not need a lot of space for the systems. Let's say with a 5 cubic meter system a day, which is for 125 people around. We only need 10 square meters for this system size, and for a rainwater tank, you would need, let's say, at least 20 times more rainwater harvesting storage volume. Yeah, so here you can see some of the references. This is a typical reference in Munich here, multi-family buildings. Now it's a system 3,600 liter a day. So maybe 80 people or something like this. This is special project here in the States. It is the George Lucas Museum. Interesting is that here the water is not only used, let's say, for toilet flushing, but also for cooling and for irrigation. But we also have other big buildings in the States. Why? It is because greywater recycling is mandatory in Los Angeles and some other cities. And the reason here is somehow funny. It's Arnold Schwarzenegger, because he was a governor in LA. And so here you can see that the regulation very often is the driver for being able to sell our components. Also very interesting is to go now into the wastewater treatment. And so we have a lot of wastewater treatment plants, and with the new directive 2020-741, we have the possibility also to reuse this water to irrigate, and especially here with all, let's say, the green experts. So this water is necessary, is mandatory. We don't have enough. We need more water to irrigate all the plants you want to plant. But the rainwater, this is the wrong, let's say, headline here, excuse me. So here it is about it's about potable water from rainwater. It's getting more and more popular. For example, you can use it for adiabatic cooling. The big advantage with rainwater is that the water is very soft, so you can save a lot of treatment, which makes the process interesting. Also, the components are saved. You don't need the softener systems anymore. Here's a nice example, let's say in LA again, for this adiabatic cooling system. And this is also a system we are proud of. It is the Rimac company in Croatia. So they decided to install a potable water from rainwater system, and for the whole factory. So it's 100 cubic meter a day, and they deliver the water now for the building, for everything. So this is a nice reference for us, of course, also to demonstrate that it is possible today in Europe. So in Germany, difficult, but in Croatia, suddenly possible. But all the other countries will follow as well. So now water, this was the information about the water reuse, and now the information about the stormwater management. Stormwater management is the opposite of water reuse. Here, we want to get rid of the water, of the heavy rainfall events, to avoid the flooding. And we have developed this plastic part. It is 1,600 liter tunnel, and you can bury this in the ground. This is very strong. It's DIBT certified. You can drive upon the system with a heavy truck, 60 tons, for example, and so on. And you can use this system now for different applications. You can install an infiltration system, attenuation, so where you can't infiltrate the water into the ground. Subsurface irrigation is a system where you can combine the attenuation and the irrigation, the infiltration also of the sewage water treatment plants, overflow, and now also water storage. And here you can see a picture. So this is the building. Now the system is new here, by the way, where we have installed different systems, the rainwater harvesting tank, subsurface irrigation, and the rainwater infiltration into the building. Here a picture how this capillary underground irrigation system is working. So the water is more or less flowing in two directions. If you have the heavy rainfall, the water is going into the system, and later through the capillary effect, the water is going to the surface, and then you can grow plants or you have the evaporation. So the whole system, we offer as well the packages. This is to make it simple for the planning engineers. Of course, we also can offer, let's say, special design systems. And such a package normally has a pre-filter section already installed, and the distribution section, and then a ventilation and maybe attenuation throttle. This is here the pre-filter. This is the throttle if you have an attenuation. So if you are not allowed to release all the water, or if you're not allowed to release the water into the ground. And then we have a special liner, EPDM liner, to seal the system. And with this liner, now we can create storage tanks. And interesting is also the iConnect. So with the iConnect, you are able to check the system if everything is okay. So you don't need to visit the site, saves a lot of money, of course. And in case something is clogged or blocked, then you can visit the site and clean the system. Here's an example how to install it. Very interesting topic is that we ship, let's say, 100 cubic meter system now on 2 pallets only. So you can save also a shipping effort with these tanks or tunnels or infiltration attenuation systems. Yeah, so now this is what we have done, and but also we are working on research and development. This is a quite big project, something around 10 million as well. We call it Acre Network for Wastewater Reuse, because we understood that rainwater harvesting is not sufficient anymore. Grey water recycling is not sufficient anymore in the future due to all the demand of water due to the climate change. We need to go a step further, and the step further now is to recycle the complete effluent of the wastewater treatment system. And here is a scenario how this should look like in the future. So we want to develop, let's say, systems not completely decentralized, so for one building, but here it is something in the middle of the municipal system and the decentralized system. We speak about semi-decentralized system. That means that several buildings are connected to one system, and then we can use the water for different applications. This is one of the next slides. Here's our team, and these are the associated partners or partners. And by the way, if someone in the group here is interested, you are invited or right now to participate. We want to share the information and are very interested in further partners. We have a very interesting team already. And on 6th of November next week, okay, maybe this is too late for most of you and also from the distance, a little bit difficult, but you are invited to participate here, and we're happy to share the information. What is the plan? The plan is that we develop a range of water reuse systems from medium size to 100 people, maybe up to 1,000 people, to close the water loop and to implement let's say, the water utility. So the operator now is not the owner of the building anymore in the future. This is the vision, but the operator then are the water utilities. And what is the reason for this? The main reason is that it's all about money, as you know, and someone needs to earn money with the water and also with the wastewater. And if we do everything by ourselves, then the water utilities let's say, are competitors, and this is not, let's say, feasible for the future. If you want to save water, we have to get everybody on board, and only with this, let's say, vision and plan, we are able, to recycle most of the water and do this in a professional manner. Okay, this is a little bit too much for today. This is all the different water qualities we want to create. At the end, we want to discharge the water only. If there's enough water, we want to also create bathing water, irrigation water, different process water qualities, but up to drinking water quality as well. Here we have some use cases. So one use case is, we have enough water. So the river here is an example. Okay, river still is full, can also be the groundwater. And what do we do with our system? We only discharge the water, but we discharge with a high quality. So we will fulfill the new requirements with the small systems as well to protect the environment and not, let's say, to say, okay, small systems, we can discharge water with a bad quality because there's no regulation. So the future, this will change anyway. In the future, we can only discharge clear water. The next then case is a shortage. So as you can see, rivers more or less are getting empty. And here, of course, we have to reuse. We can retrofit the building, but with a retrofit, we can use the water for irrigation. And if we have a new building, we also can use the water for reuse water, so toilet flushing, washing machine, and so on, because we need the separate piping. Or the acute water shortage, then definitely we have to reuse the water completely and deliver potable water quality. Yeah, then some interesting word is this AHA. AHA is the old German word for Aachen, and Aachen is the city where we are from. And it's funny, so nobody knows in our city. When you walk around and ask the people what does Aachen mean, nobody knows. But the old German word Aachen means water. Yeah, and this is the last slide of my presentation. Look forward to any questions or comments.
Yeah, thank you, Oliver, for this inspiring presentation on water reuse, rainwater management, and also the product presentation of the drainage system and addressing the general problem of water storage and also the fact that Aachen means water. That's a great fact. And yeah, so far we have one question in the chat. Maybe we can already answer it now. It is possible to use water for vertical farming.
Yes, sure, of course. Vertical farming, perfect. Definitively. So more or less all the water sources are suitable for the vertical farming. Yeah, so it can be the rainwater, it can be the grey water, it can be the wastewater we have, let's say, processed. So more or less, most of the water is available for the vertical farming. Yeah, perfect.
Okay. Participants, if you have more questions regarding the presentation from INTEWA, then you also can write them in the chat and we can try to answer them later in our Q&A session. And if there are no questions so far, then I would like to thank you a lot, Oliver. This was a great presentation. And then I would like to go on with our next presentation from Sergio Andri from HARPO. Can you share the screen?
Hello, everybody. Okay, can you see it?
Yeah, we can see it. Thank you.
Fine. So in this presentation, I want to speak about a new advanced green roof system that we have developed for water detention on the roof. But first of all, I want to move from a few words about climate change. I took this picture last summer in the North Adriatic Sea. This was a very impressive thunderstorm. But I think that this picture is not exactly what we need to speak about climate change. Less impressive but more useful is to see the titles of the local newspaper about the thunderstorm in the last years. So we can see that in 2014 there was a very strong storm, and in 2 hours fell 115 millimeters, and it corresponded to a 20 years return time. In 2022, there was probably the absolute record ever registered in our city, and in 2 hours fell 132 millimeters of rain. It was corresponding more or less to a 30 years return time event. The last one this year, it corresponded to a 15 years return time event. So to sum up, in 11 years, we have faced 3 thunderstorms of such high intensity that we would have expected to see them occur only once in 15 years. I think that this is the best representation of what climate change is. We have also another big problem. This red line represents the land consumption in Italy from the 50s to nowadays. And we can see that probably only in the last few years we have a slightly decrease in this trend. And this is the result in our city, the result of both increased impervious surfaces and of higher frequency of severe thunderstorms. And the result is flooding, no way. So how we can manage this problem, which is the main urban mitigation measure? At the moment, probably the stormwater attenuation tanks. And how do they work? We have an intense rain that generates a strong runoff, and the local regulation impose a limit. You can see this wonderful animation. This regulation imposes a limit to the discharge flow rate. I think it is worth noting that the regulation not only imposes an upper limit, but also a lower limit. So this tank is not a retention basin, but a detention one, since it must empty in maximum 48 hours. So since the required volume is merely given by the difference between inflow and outflow, in this sector we can say that flow rules, not volume. Volume is just a consequence of the flow, the discharge flow rate regulation. Okay, but if we want to scale down both the tank and its outlet from a so-called catchment scale or roof scale to a bore dimension that we can fit in a green roof stratigraphy, we have to face a big problem that this outlet risks to become so small and tight that it is strongly prone to rapid clogging. So which is our solution? We have developed this tray-based system with a water basin very small. It is 1.2 square meters for 5 centimeters depth. And it is combined with the detention channel with a very low hydraulic gradient, with important friction losses due the combination with a special porous material which has very wide pore dimension, up to 2 millimeters diameter, and an extensive network of interconnected pores. So these small but not so small channels are also very redundant. So the open dimension and the redundancy make it very tolerant to clogging. And finally, we put singular losses by abruptly changing flow direction in this channel. We have tested this new system in our facility in a rain chamber, and now I show you the result. Here you can see 2 graphs, and they are okay. With this graph, we can compare 2 hydrograms. One on the left, generated by a normal intensive green roof with a double caspated drainage board and substrate or 20 centimeters thickness. On the right side, instead, we have this new system. We've called it HARPO Flow CS with no substrate, so just the tray by its own. And these hydrograms are generated in response to a burst type rainfall. I mean a very short and intense rainfall, in this case 140 millimeters per hour and 15 minutes duration. So what can we see? That if we take the runoff coefficient as defined by the FLL norm and the Italian UNI norm for green roofs, the runoff coefficient so is the percentage of in volume of water that exits our system in reference to the rain intercepted. We can see that from a standard green roof, 24% of volume exit from the system in the first 15 minutes. On the contrary, the new HARPO Flow CS system almost had a very low percentage, 3% of the volume exits. For what concerns the attenuation efficiency, and I mean the reduction, the peak reduction of the outflow, we can see that an intensive green roof system has almost no effect in reducing the peak. On the contrary, we can measure an 88% of attenuation if we use HARPO Flow CS. Finally, for what concerns the detention volume, we can see that the normal intensive green roof had at the end of the event had inside almost 18 liters per square meter that were discharged in the next 48 hours. If we take into consideration the HARPO Flow, we had a detention volume of almost 29 liters per square meter. And the median flow rate exiting this system were 5.5 liters per second per hectare, which is perfectly inside the range that Italian regulation imposed. In these two graphs, instead, we can see the same two systems, but in reference to a volume-dominated rainfall, where I mean a very long rainfall, 7 hours, and a small intensity, in this case, 18 millimeters per hour. In this case, we can see that both had a very good performance for what concerns the runoff coefficient, because since in 15 minutes, no water exited the system, but not so good, a very bad performance for what concerns the attenuation efficiency. This is because in this very long precipitation, both reached the maximum detention capacity, and since the drainage was correctly working, the inflow equaled the outflow. But if we want to take a look to the detention volume, we can see that an intensive green roof had a much worse performance, while the HARPO Flow CS keep a very high detention volume. And I must remember that in this volume, 33.5 liters per square meter, was not included the water that can be detained by the substrate if you put also the substrate. And the detention, the medial flow rate still was in the range imposed by the regulation. Here I want to speak of other important characteristic of this new system. First of all, it has a very low slope sensitivity, since it is confined in trays. We can also put it on sloped roofs, and we can still make all the roof area to detain water. This would not be possible if we use the restriction on the outlet of the roof. In that case, in a sloped roof, we would have a detention only in the distal part of the roof. Since HARPO Flow is confined in these trays, it is a redundant system, so it is very resilient, and every tray is independent. I mean, the discharge of every tray is already balanced with its tributary area. On the contrary, if we want to work by restricting the outlet of the roof, we are in a case quite failure prone, because we have very few critical water openings, and the flow regulation require a regulation, because the ratio between the outlet and the tributary area is not constant. So you need a mechanism to regulate this flow. I think that it is also very important to speak about the sloshing risk. For sloshing, I mean the formation of a long wave, which can have an high impact potential, and that usually form on wide and shallow basins, for example, under seismic fluctuation. HARPO flow, on the contrary, since it is confined in a small trays, has not this problem of long waves. Finally, and I think that is also a very important thing, HARPO flow has no water head on the waterproofing. If we are restricting the outlet of the roof, on the contrary, we are subjected to an important water head on the waterproofing membrane and the risk of infiltration. Another interesting thing is that using HARPO flow, the storage is kept separated from the substrate, avoiding this way the ponding and the saturation of the substrate, which can bring damage to the root of plant. In which cases, in Italy, we can use HARPO flow. We have a different kind of regulation in Italy. One is that the UNI norm for green roofs, which is mainly concerned with the necessity to design and dimension the performance of drainage and outlet. In this case, using HARPO flow also in a small part of the roof can contribute to the reduction of the peak outflow, and hence, how to say, help to lighten the drainage problem at the outlet. Another kind of regulation in Italy are regulation runoff based. For example, the RIE protocol is a score based on the abundance and quality of green and permeable surfaces. So the designer has to state in the ante-operam state, which is this score, this RIE ante-operam, and at the end of the construction, it is necessary to guarantee the accomplishment of a minimum RIE score, or a good RIE score, or an excellence RIE score. And this score, I repeat, is obtained with using the runoff coefficient. So since HARPO flow has a very good runoff coefficient, it is possible to use it also in case where the simple application of extensive green roof is not enough to reach the target RIE. For example, an extensive green roof in this case I imagined bring to a RIE of 2.75. The use of HARPO flow CS bring to an excellence level, and we can balance the two to reach exactly the target we need. Finally, there are regulations which require instead a strong hydrological approach, for example, using the storage maximization method. In this case, we can give to the designer the detention storage volume, the attenuation efficiency, or the hydrograms, or even give models to describe dynamically what happens to this runoff wave. We are still developing the models, but I think that it will be soon available. Finally, I have finished my presentation. I just to make a small to recall what I've said. So this is a tray-based system. We have no water head of the waterproofing membrane, so no risk of infiltration. We have no strong restriction. The system is redundant and then failure tolerant. It is very good for a drainage improvement on the roof because it has a very high drainage capacity and a strong capacity to reduce the peak outflow. Can guarantee a good detention storage, 33 liters at least if used by its own, but we can sum up also the contribution of the substrate. In this case, I want to state and to recall that Green Roof can have a performance for what concerns the detention for the water that falls exactly on the roof, but is not responsible for all the water that falls on your catchment. So it is not possible to think that this system can eliminate the necessity to build a detention basin at the end of all the catchment, but we can reduce the dimension of that detention basin. The outflow is enough low to accomplish the regulation in Italy because it usually is under 20 liters per seconds per hectare. The system is totally passive. It doesn't need electric current, sensors, or internet, nothing. It is totally passive. And finally, it is possible to install it also on sloped roofs. So thank you very much for your attention. If you have a question, you can also write to our company. This is the email. So if you have questions.
Yeah, thank you, Sergio, for your great presentation. And I already can see one question in the chat. And this is regarding if it's possible to combine HARPO Flow CS with a cover of green roofs to higher the quality of roof membrane on the roof covered by greenery.
Yes, of course, we have developed it as an integrated board in a green roof system. We produce green roof systems, so this is our main goal. I think that it is also possible to use it with how to say, with ballast, but our main goal is green roof. I would be very interested in know which is the bad experience that you had in Norway for this system by its own, but you can write me if you want personally. Okay.
Yeah. Okay. So when there are no more questions, then I would go on with the generally Q&A session. So we can see if there are more questions in the chat. Maybe Tatiana, you can assist me. But so far, I think there are no more questions. If you have questions, then you're also allowed to speak up and ask them immediately. But yeah. Also, I think to exchange their email addresses, that's possible also to write in the chat boot. And I think you also shared the contact from HARPO. It's also available on the PowerPoint slides. But we also can send it again in the chat. Yeah, so if there are no more questions, then I would like to thank our speakers. It was 3 great presentations, really good input regarding retrofitting and the presentation of new technologies, and also great insights regarding water reuse and drainage systems. Yeah, so a part of that, I would also like to make a link to our EFB website, if you're interested in the topic of green roofs, also generally benefits of green roofs or solar green roofs. On the EFB website, you can find recent publications. The most recently was the technical guideline on biosolar roofs and a publication on benefits of green roofs, which have been released this year. And I would also like to announce some upcoming events. So this is the Nature Future 25, and it's a third edition of our annual horizon scanning event on nature-based enterprises, with a renewed focus on growth, innovation, and collaboration. And the Nature Future 25 is bringing together over 300 nature-based solutions, supports organization, and it has become a nice event to go to and to connect. So if you're interested, then you should check it out and sign up on it. It's also possible to join the event online, and it will be on the 12th of November. And then there is a next upcoming event. This will be in 2026, so there's still some time. But it's the World Congress of Building Greening. And it's also possible to sign up by scanning the QR code. And you also can find the events and also our webinars on the EFB webpage. And this webinar and other webinars, they are recorded. So if you couldn't join earlier or just right now our webinar, then there's also the possibility to rewatch it on YouTube. Yeah. Then I would like to say thank you for our speakers, to our support group, and here you have the contact from the EFB, and we are happy to connect with you, and if you're interested to become our member, here have our contacts here, and also to join us on social media such as Facebook, LinkedIn, and the webpage to stay connected with us and to be informed about upcoming events. Okay.
Yeah, thank you. Thank you all the speakers and you, Katarina, for your excellent moderation, and thank you all the participants for participation. It was very interesting webinar. Thank you a lot.
Yeah, thank you. And I think it's also worth it to go back to our chat booth, because I see we have been sharing some interesting links and contacts in there. So that's good to connect. Yeah. Then I would like to thank you, and I wish you a good day. And yeah, thank you for your participation.
Thank you. Bye-bye.
Thank
Bye.
you.
Thank you.